This video is about circular motion in radians. Okay, so circular motion. So let's just start with the definition of angular velocity, and that is change in angle divided by time taken. So I mean, you can say it's delta theta divided by delta t. You can also say it's d theta by dt. The symbol for angular velocity is omega. So omega is equal to the angular velocity, and it's the change in angle, and that is divided by time taken. That will give you angular velocity. Now let's talk about normal speed. So what is normal speed? If you remember that speed is equal to distance divided by time. Now we need to introduce the concept of the radian. Now the radian is where the angle is to be between two sides, two sides here, because these, when I say sides, I mean a straight line, and then you have the arc, which is also r. So if that length is r, if the radius is r and this is r, that's the definition of a circle. You got to have a radius, and if the arc length is r, then the angle enclosed between the three sides that have the same length of r, that is 1 radian. Now, so what is 1 radian? Okay, so what is the circumference? The circumference is equal to 2 pi r. So how many r's do we have around the circumference? So that will be 2 pi r divided by r, because there's r. So how many of these go around the circle? The answer is 2 pi. So if we say that 360 is equal, so if we say that 360 is equal to 2 pi radians, so that would mean that that's one, yes, that's in degrees, and that is in radians, 2 pi radians. So 1 radian would then be 360 divided by 2 pi. So let's find a calculator. If we can find a calculator, that would be fantastic. So far there's no calculators around. Just hold on. Let me find it. Alright, let's use this one. So we have, let's find, so 360 divided by 2 pi, that will give you what? Brackets there. So 57. So it's about 57.3. So 1 radian is 57.3 degrees. Okay, so I've just turned this upside down. So now we've introduced the concept of the radian. If we just go back to so we know that the speed is equal to distance divided by time. We need to work out the arc length. How do you work out the arc length? Let me see. So arc length. Well, we know that we know that the arc length is the whole arc length of the circle is 2 pi r, and the 2 pi let's write this down. Right, so 2 pi r divided by n, isn't it? So if we have 2 pi r divided by n, that would give you, obviously n has to be greater than 1. Yes, because if n is greater than 1, then it's going to be less, isn't it? So, okay, so we know that is equal, so we know the circumference is 2 pi r, and so that's r. Now, okay, so if we multiply the angle by the r and we get 2 pi r, because the whole angle is 2 pi, so angle is 2 pi, because 2 pi is 360, and when we multiply 2 pi by r, we get the whole circumference. And this 2 pi is the angle, isn't it? So if we substitute the 2 pi for an angle, r theta, we get arc length. But remember, this theta must be in radians. It has to be in radians for this to work. So because what happens when theta is 2 pi, you get 2 pi r, and we know that 2 pi is 360, so we get the circumference. Alright, so when we know r theta is the arc length, so let me draw a rectangle around this important information. Okay, so r theta is arc length. So now let's turn this around. What happens when the distance is r theta and we're dividing it by time? Let me see. So r theta divided by time gives you speed. So r theta, we can separate this, can't we? We can separate this like so. So r theta divided by t is the same as r multiplied by theta divided by t. It's the same. And what's theta divided by t? Well, we just here we go, d theta by dt. So the linear speed v is equal to r omega, because theta divided by t is omega and r is multiplied to it. So v and so v is the linear speed and omega is the angular speed and r is the radius. Okay, we need to talk about revolutions. Now, one revolution, oh, I can't really see that, can you? One revolution. Okay, one revolution is equal to one whole circle. Means that it goes around 360. So for example, let's just say this is spinning and you put dot there. It is spinning. So when this is spinning, this dot will go around, and then it will go back to its original place. That is one revolution. So one revolution means that it has gone around 360 degrees. And how many radians is that? 360 is 2 pi radians. So 2 pi rads. We can say 2 pi rads. So one revolution is 2 pi radians. Now we can say 1 revolution per second. Now what would that mean? 1 revolution per second. That means every second it will go around 360 degrees. So 1 second, 2 seconds, 3 seconds. So every second it will go around 360 degrees. But how many degrees in radians is 1 revolution? So 1 revolution is equal to 2 pi radians per second. So 1 revolution is equal to 1 going around once in a circle, so that's 360 degrees, and we know that 1 revolution is 2 pi. So 1 revolution is 2 pi radians per second. Okay, so how would you convert if we said 4 revs per second? That would be, because each revolution is 2 pi, you do 4 times 2 pi. So that would now be 8 pi rads per second.